Okay, boys, so I got us to go through some of the questions from the workbook for lesson 207. That's looking at the right tail. So if we take a look at the first part on 24, where you've just got to fill in the gaps, key thing is to follow the steps, and it's been laid out there for you. So the distance jumped in a school long jump competition have a mean of 170 with a standard deviation of 15. Calculate the probability a student jumped over 180 centimetres. So the steps, as always, draw a picture. So the first thing we're going to do is the mean is 170, standard deviation equal to 15. The next thing is we look for the Z value, it's 180. And the next part there is we've jumped over 180. So the actual area we're trying to find is that area there. However, our table, remember, will only give us the area between the mean and any Z value. So what we're going to do is that we know everything past the mean is equal to 0.5. If we take out this blank area away from 0.5, we should be left in with the red. Now, the important thing is the picture helps work out what you need to do. It kind of tells you what calculations you need to make. So the next thing is we need to find what 180 is as a z-score, in other words, in proportion of the standard deviation, using the formula. So 180 take away 170 over 15, which gives us, so 10 over 15, which in other words is 2/3. So in other words, 0.6667. Because we can only do 3 decimal places, we'll make it 0.667. Next thing is we need to look up that probability on the table. So 0.667, I know there is a lot going on here with these values, but I don't want to delete them. So what I'll do is I'll just change colors slightly. So I'll make it blue. So 0.667 gives us that 23 there. So what we end up getting is we end up with 0.2454, which is that part, plus this 23, which is 0.0023, because we're using 3 decimal places. Okay. Adding those two probabilities together, don't forget that 67, is 0.2477. So in other words, the area here is worth 0.2477. Now, for us to work out the probability that x is greater than 180, what we have to do is we have to take 0.5, which is the whole half, take away that white area, which is 0.2477, and that leaves us with that little bit, the difference is the little red area there, which gives us 0.2523. So that's our probability of that red area. What we're left with now is writing the probability in context. Probability in context is the probability that a students jump more than 180 centimeters is 0.2523. And that's it. Now, I wasn't too sure when I was being asked, I think a couple of boys asked me about the questions on page 25, so I thought it was worth taking a look at those questions as well. Again, same procedure as before, so remember your steps. In 2014, Americans spent 40 minutes on average per day on social media. If the distribution of these times is normally distributed, The standard deviation is 9.7 minutes. Calculate the probability that an American spends more than an hour a day on social media. So again, steps, draw the picture. So the mean is 40, standard deviation 9.7. The other thing is that we want to look at more than an hour a day. So that's 60, which means 60 must be here somewhere. And we are looking at more than an hour a day. So that's the area above. Next thing, calculate the Z-score. So it is 60, take away 40, divided by 9.7. So 20 divided by 9.7. Gives us 206. 206. 2062. 2.062. So now look it up on the Z table. So I know there's all the red there, but 2.02 means that we just have to add one at the end there. So we've got the 6, which is there, so we end up with 0.4803 plus the little 1, which is 1,000th. Sorry, 1/10 of 1,000th on the end there. So it means the probability is 0.4804 for that area. So, so the area is 0.4804. So for our probability that X is greater than 60 minutes or 1 hour, as it's going to be 0.5 for the whole half there, take away 0.4804 equals 0.0196. So now we're just left with step 4, writing our answer in context. So the probability that an American spends more than an hour on social media is 0.0196. 0.0196, which is close to 2%. So that's not the end of our question. So we've got B, which is slightly different, but we follow the exact same procedure. Draw a picture of what you see. Calculate the probability that Americans spend less than 50 minutes a day on social media. So draw what we see. So it's the exact same diagram as before. We've got 40. Standard deviation is equal to 9.7. Then we've got 50. What our Z value. However, it says spends less than that. So that's that area. Plus, I'm just going to change colors for a second. Plus, this area is less than 50 as well. Now, the purple area is equal to 50. It's because it's half the data. The median is the mean is halfway. So anything less than that must be 0.5. So we know that value already. The red part we get from the table. Next we need to calculate the Z-score. So that's going to be 50 take away 40 over 9.7, which gives us 10 divided by 9.7. Which is equal to 1.031. if we're rounding to 3 decimal places. So then the next step is finding that probability on the table. So 1.0, 3, and 1. So we have to add 2 on that 4th decimal place. So it's 0.3485 plus 0.0002, which is equal to 0.347. So using that, we know this area must be 0.43487. So that means, to tidy it up, probability that x is less than 50 is going to be 0.5 from our purple Pardenay diagram plus 0.3487. If we do that calculation, we end up with 0.8487. And then the last thing to do is find the probability in context. The probability that an American spends less than 50 minutes on social media is equal to 0.8487. So that's a couple of questions. Hopefully you notice that in both questions we follow the exact same procedure each time. We let the diagram help us to tell us what calculations we need to make, and that we're really careful with our calculations as we go through. Moving forward, it's really important we spend a lot of time practicing this and making sure we've got those steps sorted. So again, practice, practice, practice. The good news is this week you'll be doing a bit more of these sorts of questions as well.